welcome back to Everything Swift. Today we'll be tackling Leetcode question 55 titled Jump Game. Basically, we are given an integer array here represented by this nums parameter, and we're supposed to find out whether we can make our way to the end of the position jumping from numbers to numbers, right? So let's take a look at this example for better clarity. So we're supposed to find out if, let's say, we start from the beginning index, right? Can we make our way? Can we jump all the way to the end of this array index here, right? So it being value 2, it has two options. It can just jump 1 or it can jump 2, right? So it can jump from this index to 3 or this index to this value 1 here, right? Because it's value 2. And the same for 3, right? 3 can jump 1 or 2 or 3 all the way to here, right? And 1 obviously can only jump 1, which is the next one here, and 1 can jump to the next one, which is 4, right? So if we take a look at this, the answer is true, because 2 can essentially jump to 3, and 3 basically can make all the way to 4. So we reach the last index, and that is what we are trying to find out here. Or a tree can jump to 1 and 1 can jump to the next one and 1 can jump to the end, right? Or 2 can jump 2 spots to 1 and then 1 can jump another spot and then jump another spot to the end, right? So basically we're supposed to find out if uh, given the value that we are at that particular index, can we eventually find our way to the end of the array here, right? So, how do we solve this, right? There are probably different solutions available. I think one that really comes to mind is probably dynamic programming, where we solve the sub-problems at each index, and then we figure out whether it is possible at every index to reach the end here. The only problem with dynamic programming solution for this question here is it is not the most performant, because the time complexity for this dynamic programming in this question will probably be O of n to the power of n. And if we do try to optimize the dynamic programming solution, we are probably going to use extra space for memoization to store and cache the solution visited path already in the dynamic programming solution. So basically, in general, the optimal solution as compared to the dynamic programming one is that the dynamic programming solution is much poorer in terms of the time and space complexity. So for today, for this question, we are going to use a greedy algorithm to solve this problem here, where it will give us a time complexity of O of n, and actually the space complexity is O of 1, so much better than the dynamic programming solution, right? And how do we do that in general is we are going to start from the last index, and then we're trying to make our way back all the way to the first index here, right? So when we use the greedy solution, we are asking that, okay, can this index here reach the last index? In this case, yes, because 1 can reach, basically jump 1 and it will reach the last index. What we're going to do then is, because we're going to shift the goal from it being the last index to this particular index here, right? And then we proceed to ask the same question. Can this index here jump to this new goal that we have, right? The goal here has been shifted from the n index to this position. So can 1 make its way to this index here? Yes, it can, because it can just jump once, right? And for it, we know that if it can jump to this position, we know we are still in on the right track to reach to the end of the index, because this index here can jump to the last index here, right? So all we have to do is find out, like, if this number can reach to this index, then we know that it can definitely reach to the end index, right? So because it can do so, we continue to shift our goal again to this particular index. Now we ask the same question. Can 3 make its way to this position? Yes, it can, because 3 can jump either 1 spot or 2 spot or 3 spot, right? So we know 3 can jump all the way to the end, and that's perfect, but it doesn't have to do so because 3 can just jump to 1, and 1 can obviously jump to this next position, and this one can jump to the end position, right? So we know that 3 can make its way to this particular index here. So we shift the goal again to this position, and we ask the same question. Can 2 at this index 0 jump to this new goal here? Yes, it can, because it can either jump 1 or it can jump 2. And we already solved all the previous one, right? If we can make it here, we know that it can make it here, here, and it being this index can also make it to the end. We know all we have to do for this position value 2 here, index 0, all he has to do is make sure we can jump to this spot, and then we know that it's possible for us to make it to the end, right? So that being said, we shift the goal again to the first index here, index 0, and that's how we know that we are able to reach to the last index, it being the last we finally arrive at index 0. That's how we know that we can make it to the last index here, right? So I know it probably is a little bit difficult to envision it, so I'm just going to jump straight right into the code. It's really simple, and yeah, let's just jump right into it, and probably it'll give you better clarity on my explanation earlier. So as always, I'm just going to check if it's empty. If it's empty, I'm just going to return false, because if there's no operation to check, then let's just exit out of this function scope as fast as possible, just for minor performance gain here. In the world of Leetcode, unless specified in the question, we probably don't have to worry about it, but it's just a habit of mine. Just a small thing, small performance gain, no harm done, right? So as explained in this greedy algorithm solution that we are going to use, we are going to start from the last index and work our way all the way to the 0th index, right? So what we're going to do is get the last index as a variable, and let's get that. So that's the last index here. So the last index represents the goal. We're going to shift the goal each time if we know that, okay, the previous index can actually make its way to that particular last index, or our goal, so to speak, right? So what we're going to do here is we're going to enumerate uh, in a reverse order fashion. So I'm just going to use a for loop and reverse here. So basically we are starting from behind of the array instead of looping from 0 all the way up, right? We are doing it in a reverse order fashion. And then what we're going to check is if this particular index plus this current value of this index, is it bigger or equals to this last index? Is it bigger or equals to our goal? If it is, then let's move the goal, right? Last index equals to I, right? And as we noted earlier, I is basically in a reverse order fashion, so we are basically moving our last index backwards, right? So we only do that if it's bigger or equals to last index, because that means we know that it can arrive at that particular index. It can jump to that index, right? So once this for loop operation is done, we just basically have to return if the last index is 0. If it is, it represents that we have arrived at our first value of the array. So that means we have successfully checked that every position from the last index is each value in between them can actually make its way to eventually make its way to the end index of the array, right? So that's why we check if last index is finally equals to 0. If it is, basically we traverse and essentially make it through the way from the last index here all the way to the 0 index. So let's try and run this and see if we pass the test. There we go. That's good. Let's go ahead and submit this. And there we have it. That is the solution. Basically, the reason why we use greedy for this question here as compared to dynamic programming one is because, as we can see here, greedy solution is time complexity is O of n, and we basically use no space, which is O of 1. So it's definitely more performant as compared to the dynamic programming one, and obviously less complex in terms of the code. But yeah, so that's all for today. If you guys enjoy this content, please feel free to subscribe and hit the bell notification so you guys know when I post my new video. And as always, I appreciate it if you guys can share this channel with all the Swift enthusiasts or iOS developers that you know, because I'm trying to grow this channel as well. So much appreciated, and thanks for your time. Take care and bye bye.